and welcome to lesson 3.7 review for vectors test. Here are the topics that we covered in this class, and again this should be review. If you need any help with this, please let me know. All right, so scalar quantity or a scalar has just a magnitude. Sorry, started off not the right thing there. Okay, just has a magnitude. So an example of that would just be distance. Okay, so example could be 10 kilometers. Okay, versus a vector, and a vector has not just a magnitude, but a magnitude and a direction. Okay, so a magnitude and a direction. So an example of this would be displacement. So example could be for that 2 kilometers north, 40 degrees east. Okay, so it has the magnitude and the direction. Okay, when we're taking a look at drawing a scalar, okay, if we take a look at drawing scalar AB, it just looks like that. The magnitude is identified by the length of the line. Whereas when you take a look at drawing of a vector, it definitely will have a direction attached to it, okay? So basically, you go from tail, which is the start, to the tip. This is the direction the vector is going, and of course you have the magnitude with the length of the line, and a vector is shown with an arrow over top, okay? All right. Next, we're taking a look at direction bearing. Just remember, with a direction bearing, we start at 0 degrees being true north. Okay, and then 90 degrees as we go around clockwise, 180 degrees, 270 degrees. Okay, so for an example, if I give you this and say there's a 20-degree angle in here, to find your bearing, it's going to be 90 degrees, because you start at 0, go 90 this way. Okay, then you're going to add 20. So that was going to be equal a bearing of 120 degrees. Remember to use 3 digits, folks. So if it's like a 48 or something like in here, you know, 76 degrees, it's going to be 076 for the bearing, okay? Again, that starts from the true north at 0 degrees. Okay? A quadrant bearing deals with north, south, east, west. Okay? So if I draw my little, I always remember the acronym never eat sour watermelon. It's up to you to decide which way you want to do this. Okay? And say I had a similar angle here, folks, and that was 20 degrees here. Well, you could argue that, hey, it's 90 plus 20 degrees from the east, but you always take the shortest distance. It's actually shorter distance to go to the south from that vector. Okay? So what we're going to do is say, hey, if that's 20, then this has to be 70 degrees. So to do the quadrant bearing, it's going to be south. That's where we start at. And then we go 70 degrees towards the east. Okay, the only other part I forgot to do, folks, is to put an arrow on that. All right, good. Equivalent vectors have equal magnitude and direction. Okay, opposite vectors have same magnitude, but opposite direction. All right. Number 5, we need to take a look at the vertical component and the horizontal component, okay? And remember, we're going to be using trig to do this. So say we have a vector. Let me just draw one here, okay? And we'll call that vector V, okay? And notice that vector will have a horizontal and a vertical component. So if I draw a 90-degree triangle to form it with it. Okay, my horizontal part is going to be my x vector, which is going to deal with the horizontal component, whereas my vertical is going to deal with the y. So using, ladies and gentlemen, the theta in the given angle, okay, we know that when we take a look at the vertical component, we're comparing the opposite side versus the hypotenuse, which is the sine. So sine theta equals the value of the y vector over the value of the v vector, okay, or the hypotenuse in this case. Okay, so to cross multiply or simplify that out, the y component or the vertical component equals the absolute value of your vertical component times the sine of the angle. Likewise, if we go to do the horizontal component, okay, maybe we'll just change this to blue and then they'll kind of match. Okay, so I change that to blue. Horizontal component based on the angle theta, that's the adjacent side, and with the vector component, it is the adjacent and the hypotenuse, so that tells us we're going to use cos theta. So cos theta equals the x component over the vector component. Okay, cross multiply, that tells us that the vector x or the horizontal component equals the absolute value of the hypotenuse vector amount, or whatever you want to call that, the diagonal side, times the cos of the given angle. All right. Next, you will notice that we're doing adding vectors, and remember, when you add vectors, it gives you the resultant. And remember, you can do the head to tail triangle method, or you can still do the parallelogram one. However, head to tail is most common, and use this with trigonometry to solve many word problems. Okay. Remember, when we subtract vectors, that we add the opposite. Okay, and to add the opposite, remember that if you had something like, if you said AB subtract BD, okay, that's going to equal AB, and you're going to add the opposite, so DC. Okay, that's how you do that. So remember, you change the direction of the second vector, then use the head to tail method, which means you're actually adding it. So you in fact will be finding the resultant after you create the opposite to add. All right. Number 8, solving problems. Okay, when two or more forces act on an object, you can use vector addition or vector subtraction to find the magnitude of the resultant force. Okay, and remember, to find the magnitude of that, you're going to use trig to do that. Okay. All right. If the opposing forces are 90 degrees from each other, then you can use Pythagorean theorem or SOHCAHTOA. That's because they are 90 degrees. In most cases, they are not, but in some cases, you can do that. Okay. So let's just take a look at example of two things here to set up how you could do this. Okay, so say we have the resultant here, which is formed by taking two separate vectors. So say this is vector A, okay, and this is vector B. Okay, and vector A and vector B create a 90 degrees. So to find the magnitude, that's going to be the distance measurement, not the direction. It's going to be a squared plus b squared, and then take the square root of that, right? So this gives you the magnitude. Okay. Whereas when you're trying to find the direction, that ties into the angle. So to tie into the angle in this case, ladies and gentlemen, you're going to realize, hey, I've got A and B, so I've got my tan ratio, so tan theta equals, in this case, it's going to be B over A. And remember, when you're finding the angle or the direction, you've got to use the tan inverse of B over A. And this gives you the direction. All right. Good. Last part here. If all the forces form an oblique triangle, okay, that's a different approach. We're going to use the cosine law to find the magnitude. And then we're going to use that information to help us create a match to do the sine law to find the direction in most cases. Okay, so I'm just going to move this down, hopefully. Let's see if I can do this quickly. I apologize. Let me just give some enter here. And I'll do an example here. All right. So taking a look, folks, if, say, I have an oblique triangle that's formed by two vectors. So here, let's do vector D here. Okay. And maybe vector E here. Okay. And then to find the resultant, it's going to be from the tail to the tip for your resultant. Okay. So in this case, to find the resultant, you're going to have to find this interior angle using some geometry, or maybe it's given. So let's just use an example that's 120. To find the R in this case, we're going to set up the cosine law. I'm going to do the square root sign right away. So it's going to be square root of E squared plus D squared minus 2 times E times D times the cosine of 120 degrees. Okay, and that's where you can find the magnitude. Okay, once you found the magnitude, that's going to give you what we call a match. So remember, you will know this as a match, and then you could find the angle or the direction theta, which is right here. Okay, so to do that, you're going to use sine theta, in this case over the measurement of E, divided by our match, which would be sine of 120 degrees in this example, divided by your answer that you got in A. So that would be this magnitude answer goes in here. And then remember, because you're finding an angle, guys, that it's the sine inverse of, so sine inverse of E times sine of 120 degrees, all divided by your answer. Okay, and this gives you the direction. Okay, well, it gives you, so it gives the angle, and then you need to remember to fix it to a bearing. Sorry, guys. So fix it into a bearing. You can use a quadrant bearing or a direction bearing. All right. So for your homework, ladies and gentlemen, I want you to read the checklist on page 59 and see the handouts on vectors. And I've got some practice questions for you to get ready and familiarize for your upcoming test. Please hopefully tell me if there's anything wrong with this study sheet, and if you have any questions, again, come see me, and let's be really successful on our next unit test. Okay? See you and have a good day.